How to make slope fields. Yay! So slope fields are used by a derivative function. So let's say you have y equals x squared. Apologize for how unsteady the camera is. You take the derivative, y equals 2x, and being that it is the first derivative, it's y prime equals 2x. The first derivative is going to represent the slope of the function, so whatever point you may use on a graph, you plug in to the first derivative, and you'll find the slope for that point. So our first derivative, y prime, equals 2x. Let's say, for example, you have the point, bad focus, x equals 1, y equals 0. Y is going to be irrelevant in this equation because there's no y added to the first derivative, but you plug in the x values. So when x equals 1, you plug it in there, so y prime equals 2. So that means the slope at x equals 1, y equals 0 is 2. And all you do is make a slash. A little slash, I should say, that indicates the slope, so be kind of like that. A little line that represents a 2 slope. Alright, and then since we know that whenever x equals 1, y prime equals 2, you can do the 2 slopes all the way up for any value where x equals 1. Kind of like that. So if you have x equals 2, you'd plug in 2 right there. 2 times 2 equals 4, so y prime equals 4 when x equals 2. So it's going to be a slope of 4, which is going to be a pretty vertical line. If I could do this more exactly, I would, but kind of get the point. 3 we're not going to do because that's going to be a lot higher slope, and I don't want to just be drawing a straight up line because then that may throw off how people look at the graph. But then also on the negative side, you'll do the same thing. So negative, when x is negative 1, y prime equals negative 2. So you'll have a negative 2 slope all the way across here. And for this equation, it'll be pretty much a reflection on the opposite side of the graph. So at negative 2, it's going to be negative 4 for the slope. 3's, it'll be a slope of 6, and negative 6. So there you have it. That is slope fields. Dun dun dun.